Okay, we're running. So let's work this problem. What are we going to do first? What do we always do first?
Free body diagram.
Draw a free body diagram. So I'm going to do that. I'll come over here and draw my free body diagram. So I'll draw a line that indicates the beam. And then I will assume directions for my pin at A. How many unknowns at the pin?
2.
2. So I'll assume that one is acting up. I'll call it AY. And one is acting to the right. I'll call it AX. And over here at B looks like a roller. And I'll assume that that's acting up. Okay? Right out in the middle, I have a 24 kilonewton force, and that's acting at 6 meters and 6 meters. Now, what am I going to do with this distributed force over here? It's easiest to always find the concentrated equivalent force. So what's basically the area under the curve? What's the area under the curve? 6, yeah. So it's just 2 times 3 is 6. So my equivalent force will be 6 kilonewtons. And where is it located?
1.5 meters from B.
Yeah, the center, right? And the center is half the distance, half the 3 is 1.5. I'll just write that on the end out there. So in the strategy that I've been talking to you about earlier about drawing a good free body diagram, that's a pretty good free body diagram. I mean, I don't see anything that's missing. You guys see anything that's missing? It's stable. It's determinate. So now we're ready to go. So in our strategy of solving the problem, would I want to sum forces in the y direction first?
No.
Why?
Because you have 2 unknowns in one direction.
Yeah, 1 equation, 2 unknowns. That's probably not a good place to start.
Start with X.
Sorry?
Start with X.
What?
Start with X.
I could sum forces in the x direction, right? I have only one component, AX. Get that. So what I'm going to do is also I could do what? I'm left with one equation. Sum force, sum moments, right? Let's just do that one first. So the way I like to do it is I first tell you what my sign convention is. I do right-hand rule for my sign convention. So I'm then going to sum my moments at point A and make sure they're in equilibrium. So that's not an arbitrary equation. That's a pretty important equation. First of all, it's saying that you're summing moments and they're equal to 0 for equilibrium. And I've also established what my sign convention is. Now, you can do whatever sign convention you like. It doesn't matter. Just be consistent. So now I'm going to sum moments about A. So let's look at the 24 kilonewton force. Is it creating positive or negative moment about A?
Negative.
Negative. So I'll have the force, 24 kilonewtons. And what's the moment arm? 6 meters. Okay. What else do I have? What about my concentrated equivalent force? Positive or negative moment about A? Negative. So I got 6 kilonewtons. And what's that moment arm from A? Looks like 12 plus 1.5 is 13.5. Does that sound good? What else have I not considered? BY going to create positive or negative moment? Positive. And what's its moment arm? 12. So all I have to do now is solve for BY. I'm going to let you guys tell me what that is. I don't know what it is.
18.75.
Does anybody else get 18.75?
Yes, sir.
Going once? Going twice? Oh, we got 3. Okay, great. 18.75. And it came out positive, right? So that means what? That means my assumption for the direction of BY is correct. So now we can go any way we like. We can sum forces in the Y or the X. I think I'll save my X equation for last. So I'll sum forces in the Y direction, and I'll assume that up is positive. So let's account for all my Y forces. I've got AY acting up plus BY. And then acting down, I have my applied 24 kilonewton force and my concentrated equivalent force. And we know By, so we can just stick that right in there, sign and all. So even if you had made a different assumption and you'd have found out that By was negative, do you go back to your free body diagram and make a change in this? No. Never change your free body diagram. Stick with it and go. So then when you come down to here, you would just plug in your value, whatever it happens to be, positive or negative. Don't go changing stuff midway through the problem. That's a good way to get confused. Remember, the exam, you got about 15 minutes of problem max. So you might be under a little time constraint. So make your assumption, just go with it, let the sign carry through. So with that said, what should AY be? 11.25? I like that. And also positive, so what? Assume the right direction. If you get a negative and you assume the wrong direction, it's not a comment about your mental or emotional state. It's just a sign, right? It's not your bank account. It's just a sign. And then finally, I'll assume to the right is positive, and I will sum forces in the x direction. Make sure they're all equal to 0. And what do I have? AX. That's a pretty easy one to solve. AX is 0. Okay? Pretty easy problem to start off with. You guys got any questions about that? This would be a nice one to have on the exam, huh?
Yeah.
It won't be on the exam. But I just let you know it'd be a nice one to have. Okay? All right. I'll stop it.